Hello and welcome to the part 1 of Synchronous Reluctant Motor series. My name is Tuan Nguyễn, founder of Power Electric and Motor Drive channel. In this channel, as you know, we share a little bit knowledge about the power electric and motor drive on various tutorials of this machine. So if you have not seen my channel yet, so please go into the Tuan Nguyễn channel. Here we will find out almost a tutorial about the AC or DC motor, such as the BLDC motor, apply the sensorless control algorithm. For example, battery discharge, some example of the electrical vehicle configuration for hardware include demonstration, or other motors such as switch reluctant motor here and the PNRM motor here, and some kind of the motor, BLDC motor, and power electric also. So in this channel, we will share all the material, all the slide presentation, and the other simulation file to our community. Okay, so come back to this present today. This is the part 1 of Synchronous Reluctant Motor Drive and the Control. In this part 1, I'm going to introduce synchronous reluctant motor and their principle, their advantage and disadvantage of this kind of motor. Then the part 2, we are going to deploy on a Matlab Simulink environment. Firstly, for the motor control subsystem and the inverter subsystem. And the final part is part 3, we will deploy the speed load controller and current controller after our my YouTube channel. Okay, so here is the agenda of this the presentation today. First, we are going to introduce and definition of the synchronous reluctant motor, and we are talking about the principle and construction of this machine. We talk about the advantage and disadvantage compared with other AC motor. And finally, we discuss about the motor drive and the control of the synchronous reluctant motor. And part 2 and part 3, we will find the Matlab Simulink simulation. And finally, the conclusion. And the idea is that after reviewing the throughout of this course, we will be familiar with the basic of this synchronous reluctant motor, and we will confident to build their model drive by yourself. Okay, so let's get started with the synchronous reluctant motor introduction. So as you know, the synchronous reluctant motor is one of the oldest type of electric motor and has from time to time attracted the effort of a considerable number of investigators. The first one, so the different type of motor classification. We have the rotary machine and lining machine. In the rotary machine, we have the radial plug, which is contributed by the AC or DC motor. For example, of DC motor, we have the permanent magnet stator, or the AC motor, we have the induction machine, which is asynchronous machine, and the synchronous machine. And our machine, synchronous reluctant motor here, is kind of a synchronous machine. And for the leading motor, we have the axial plug and chamber plug machine. And we have the special machines such as fluid DC motor, or other switch reluctant or stepping motor. The figure 2 here shows the basic structure of the synchronous reluctant motor. The synchronous reluctant motor is an electromechanical energy conversion device which converts electrical energy to mechanical energy, and the motor also always runs at synchronous speed due to the magnetic locking between the rotor magnetic field and the stator magnetic field. In the DC motor, we will see the torque is produced due to the interaction between the stator and rotor magnetic field, which also known as the Lorentz folklore. However, in the switch, in the synchronous reluctant motor, it is follow the reluctant principle, which means the constant reluctant torque is produced in the rotor which cause the motor to run. Next one, we will talk about the principle and construction of this machine. So, the fundamental concept behind the origin of this motor is reluctant principle. In this synchronous reluctant motor, the field V is produced by the sinusoidally distributed winding in a slot stator, and it links the stator and rotor through a small air, exactly as in the traditional induction motor. And stator current is responsible for both the magnetic direction, the main field, and the torque version, which is trying to reduce the field distortion. That can be done by controlling the current angle of the machine. So as a various AC motor, the synchronous reluctant motor, we have also the voltage and current equation. This figure 4 shows the equivalent circuits of three-phase of this machine, and in the left side is the voltage and torque equation, and this is the construction motor of a synchronous machine. As you know that the stator winding is of a three-phase in nature, which means that they are connected in a stator or delta. The reason for this, when they are excited with a three-phase supply, they must produce a rotating magnetic field, and the stator winding image of a sequence still standing. And rotors and rotor winding are made up of the ferromagnetic material. The reason for this is that since the rotor has to align with stator magnetic material as per reluctance principle, therefore the reluctance of the rotor winding must be least. And the advantage and disadvantage of this motor. Due to its magnetic locking principle, the machine is able to produce constant speed under all circumstances. Any change in load, like underload or overload, will be overcome by the synchronizing torque, and the speed will be maintained in all respects. And due to the reluctant principle, it does not need any starting method, while in a synchronous motor, that is starting method and not a self-starting. And the self-starting aspect of the machine make the machine more robust. And due to the less complicated structure, it requires a less maintenance fee, and then no ripple torque compared with the switch reluctant motor. And besides that, so far we have the disadvantage. Yeah, and you know the biggest disadvantage of this motor is to constant speed application and no speed control is possible. Then the speed cannot be varied. And due to the need for both stator and rotor magnetic field, the machine is also known as a doubly excited machine. We need both for two excitations, one for stator and one for the rotor. And due to the presence of the two-phase winding and copper loss are more as compared with the DC motor. Okay, so finally of this, we are going to discuss about the motor drive and the control. As you know, this figure 6 here show the traditional approach to control three-phase AC machine. As you know, we have the two blocks here. The block A represents for the provide the reference current to the block B, which is the vector control. So figure 9 and figure 10 are commonly adopted for the vector control based on the stationary and synchronous frame. This is very well known for traditional control current control algorithm. And this is the detail ID and IQ. As you know, the synchronous reluctant motor will the current control of this will similar with compared with PMS motor. We have the EI, the ID control, and the IQ control also. And finally, we have found at figure 9 of the general control configuration for the synchronous reluctant motor drive. We have here a switch synchronous reluctant motor, and our three-phase converter will be using the IGBT or MOSFET, and the pull is the SPM or the PBKM technique. And we have the path and class transformation from two-phase current controller to ID/IQ or VD/VQ, and we have the speed controller is the outer loop. As we can see in the figure 11, in the detail of rotor speed, the ID/IQ current regulator for synchronous reluctant motor drive, considering also the effect of saturation on the LDS and L3S. And we have to control the detailed variable DQ current limitation function. And finally, the speed controller is the out group using the PI traditional control. And we have the saturation of current controller here. Okay, so finally we have to take a look at the control block diagram of a synchronous reluctant motor. We have the first one is synchronous reluctant motor block, and second one is the inverter block. The third one is the path and class transformation from EDEQ, the current controller, which transform from using the speech encoder or the measurement of current controller here through path and class transformation. We have the current reference for the inverter, and the outer speech in the outer loop in the speech controller. We will deploy the PI controller and also. So finally, the reference of our presentation, we would like to thank you our three papers such as the field-oriented control of a synchronous reluctant motor of either Takeuchi, Matsuo, and Thomas. And the second is the synchronous reluctant motor solution, the new alternative in AC drive. And the third one is the synchronous reluctant machine in variable speed drive application. We will find it on Google of this one, and we will see the various papers on this. I will show you some kind of this. The first one is the paper of synchronous reluctant motor solution. In this paper, our introduction and the motor control technique, and modeling the synchronous reluctant motor by on PD and PQ equation. And finally, we have the traditional approach, the overview of block diagram of this machine, and current controller and speed controller also. And finally, the possible scheme of lag observer for this reluctant motor. So, okay. The second one we will find is field-oriented control of synchronous reluctant machine. So, similarly, they new degree equation of this machine, and they have the top equation here, and they calculate the ID and IQ. Wow, very expensive, very excited. And this is the equation for field reckoning control also. Okay, I will share the public for all the kind of paper. This one. Okay, so now come back to our presentation. I will simulate I will apply this one to the Matlab Simulink environment. Okay, so now we are going to implement in the Simulink device. So for the box, we will take the synchronous reluctant machine here in the library electrical, mechanical, reluctance stepper, and this one. And we will take care of the physical simulation in order to deploy this machine. So first one, we will call the synchronous. Reluctance. Okay, and we will take this one. The number of control key. This one will LD, this one will Q, and this one will L0, and this one the starter resistance VS, and we apply OK. And the second one, we will check the temperature by typing the temperature here, click right here, and we will click lock this one, and the curl glitch here, and we have the sub item, subsymbol here, to the measure, and the sub function here to get driver. And the one we will get the DC voltage by the battery. With the HP accurate, and this one will correct the V nominal, and the internal is 0.01. Okay. And the final one is capacitor here. So we see. Okay. This one we connect by the sub item, and we call the voltage measure. And we have the exposure here, and this one we measure the curve, We use a current sensor and to replay. The missing block. And physical to simulate. And we have one photo with the replay IDC and flow. And this one we put right. This one we put left. Okay. And I will call a mask here. For example, this here. Okay. And finishing here. And this one we have an exposure. And also we have the bit measuring here. And then we have the distance serve. And we record here the BDC and the global here. Okay. And same as so, we take care of the right, and this one is left. I will want to content preview and recreate a match for this by typing display footage here. rotation, no motion sensor. And this one we call the F also for the global. Okay, and this one the T for the top. We use the power physical model to Simulink model using this one, and this one we have double tool, and we call the torque measure. We put the TP show frame and put the global here. Okay. And we have the 2 equal 1 and the 1 is left. And this one creates a match. So display top display. Okay. And this one is really good. Color. Simulink and this one the condition block. In the and this one we assign the 10,000 and the negative tempo. Okay, take a look here. We connect here, and this one with load. Last step. Assign step time is 0.05. I'm going to leave as no, 21. And shuffle configuration. Okay, and we're done. And the final one in red paper, it is deploy the full pattern for the paper. So this one we have the input, control the edge, and we have the result. Secure, merciful, and we have merciful here, Simulink. Here we are physical. And we copy the text here. And we cut the chipboard. Okay. And we have the definition of Z here. Control Z. And this one here. I don't want to do. And we have one computer from somewhere to generate. Build it right over here. Go. Okay, so we have one more subsystem here and we call the control. And finally one subsystem here. And we will see the result here. And call the result. Okay, so in this video we are going to implement the synchronous reluctance module using the physical model and the converter for three-phase converter. And the next video we are going to discuss about the control loop, the outer control loop in speed converter, a speech controller, and the inner current controller. So I will see you in the next video. Thank you.